Galaxies, other objects, and the expansion of the universe. In this lesson, we're talking about the types of galaxies, asteroids, meteors, meteoroids, and meteorites, comets, and the expansion of the universe. Galaxies. Using a system invented by Edwin Hubble, astronomers classify galaxies into three major types: spiral, elliptical, and irregular. The sizes of the three main types of galaxies span a wide range. We have everything from dwarf galaxies, which contain about 100 million stars, to giant galaxies, which contain over 1 trillion stars. Now, spiral galaxies look like a pinwheel from above. You can see the arms spiraling out from the center. Now, an example of a spiral galaxy is our Milky Way galaxy. Now, this isn't a picture of the Milky Way galaxy. You can't take a picture of something while you're inside it. So think about the city where you live. You can't take a picture of that city from above while you're inside that city. And since we're not able to get outside the Milky Way galaxy at this point, we can't actually take a picture of our galaxy. What we can do is get a general understanding of what our galaxy looks like based on astronomical data, mathematics, as well as pictures of other galaxies. Next, we have elliptical galaxies. They range in shape from a perfect sphere to a stretched out ellipse. An ellipse is more like an oval shape. They contain some of the oldest stars in the universe, and over half the galaxies are elliptical, and they make up the larger ones. So you can see our elliptical galaxies there and there. Irregular galaxies is our third type. It's a none of the above kind of category. It's neither spiral nor elliptical, and it's made up of newly formed stars as well as old stars. So it's kind of like more just a general clumping of stars in a very non-distinct shape. So you can see two examples here. You can see their shapes differ greatly between each other as well as compared to the ones we've already looked at. The local group. We combine galaxies into groups based on location. The Milky Way belongs to a group of about 40 galaxies called the local group. The diameter of the local group is about 10 million light years across. After the local group, then we get into larger groups, and larger and larger and larger. It's similar how you could classify where you live based on your city, country, hemisphere, planet, etc. Now, how many galaxies are there? Well, there are about 24 galaxies in the universe for every person living on Earth. So keep in mind, this is not to scale. And if you keep in mind the size of galaxies, it gets to be pretty mind-boggling about the immense size of the universe. Other objects in the solar system. So other objects include things like asteroids. Asteroids are small rocky objects that orbit the sun, and millions can be found in a ring called the asteroid belt, which is located between Mars and Jupiter. And you can see it pointed out right here. So this is Mars right here, and this is going to be Jupiter right here. And the asteroid belt is right between them. Now, the asteroid belt isn't like it is on movies, where if you fly into an asteroid belt, you need to zigzag out of your way so you don't crash into one. Although there are millions of asteroids in the asteroid belt, they are still really far apart because space is so huge. If you were in the asteroid belt, you most likely wouldn't be able to see any asteroids because they're so far from each other. Now, asteroids range from anywhere from 6 meters to about 933 kilometers. The dinosaur killer asteroid, the Chicxulub asteroid, was about 10 kilometers across, and it landed near the Gulf of Mexico. And you can see the impact site highlighted right here. This 10-kilometer across asteroid created such devastation on Earth that it wiped out most of the living things, including the dinosaurs, which, in hindsight, is a really good thing because it allowed us to evolve. Now, even with our advanced technology, asteroids are still a significant threat. Unfortunately, asteroids are dark objects in a dark sky, so unless we're looking at the exact area where those potential asteroids are, we might not even see one coming. So even an asteroid large enough to destroy most of life on Earth might not be seen until it's too late. Meteors and meteorites. Now, in addition to asteroids, we have other names for objects traveling in space. First thing is a meteoroid. A meteoroid is a lump of rock that is pulled down towards Earth by gravity. How do we differentiate an asteroid from a meteoroid? Typically, a meteoroid is a smaller asteroid. A meteor is a bright streak of light across the sky as a meteor burns up. So as that meteoroid enters Earth's atmosphere, it encounters a lot of friction, which causes it to burn up. As it burns up, it creates a fireball in the sky, and that's what we see as a meteor. You can see it right there. So this would also be your shooting stars. Now, a meteorite is a large meteoroid that doesn't completely burn up in the atmosphere. So a meteorite is what's left over after a meteor has started to burn up in the atmosphere. So we're going to have our meteoroid. It's going to become a meteor as it burns up in the atmosphere, and that's going to become a meteorite as it impacts the ground. Now, in February 2013, there was a very interesting meteor explosion over Russia. The meteor had an initial mass of about 12,000 to 13,000 metric tons, so it's heavier than the Eiffel Tower, and it measured between 17 and 20 meters in size. It was moving at approximately 18.6 kilometers per second, so that's over 41,000 miles per hour, almost 60 times the speed of sound. It exploded 23.3 kilometers above the ground, and it released 500 kilotons of TNT, 20 to 30 times more energy than was released from the atomic bomb detonated at Hiroshima, but without the radiation. Keep in mind, it also impacted over 23 kilometers above Earth's surface, and that reduced the impact as well. The explosion injured thousands due to the release of energy, which created shock waves, shattering windows and toppling smaller structures. What I'd like you to do is pause the video and watch number 3. It's a really interesting look at the meteor explosion over Russia. Now, the last type of object we're going to talk about are comets. Comets are chunks of frozen matter, usually ice, that travels in a very long orbit around the sun. Most are found in an area known as the Oort cloud, which is far beyond the orbit of Pluto. Comets have tails, which are a few million kilometers long. When the comet approaches the sun, it's warmed. The frozen substances become gases, which are then pushed outwards by solar winds to produce the bright tail. So you can see in this picture right here, the sun is located right here, and this is the comet. You can see the head of the comet right there, the bright streak. Now, the part of the comet that's facing the sun is being warmed very quickly by the sun, melting a lot of the ice and creating a gas. That's this gas tail right here. And if you look in the bottom right-hand corner, that's a very famous comet. Most people have heard of it. It's called Halley's Comet, and this picture was taken June 6, 1910. Now, since comets orbit the sun, so if the blue circle is the Earth, the red circle is the sun, and the black speck over here is the comet, every once in a while, the orbit of that comet, as it travels around the sun, will bring it close enough for us to see on Earth. Not all comets will follow a path that we can see, but some comets, like Halley's Comet, will come by every once in a while as they're traveling around the sun. Now, the last part of this lesson will be talking about how the universe was created. Now, the name we give this event is called the Big Bang Theory, even though in actuality, there was no bang, as they say. A better, more accurate name would be the Big Expansion Theory, but that doesn't have the same kind of ring to it. Now, let's break down the Big Bang. The universe started out as an extremely compact, small, and unimaginably dense structure. Think of everything in the universe, all the galaxies, all the objects, all the matter, everything compacted into a minusculely small sphere. And about 14 billion years ago, it started expanding to the point where it is right now. The first second. Now, at time equals 0, that's when the Big Bang occurred, or the Big Expansion occurred. We do not know what happened at time 0. In fact, we don't know what happened at the very start, even just after time 0. But we do know what happened shortly after that. And the reason we don't know what happened at time 0 is that the mathematics get really funny when you start talking about an object that is that dense. So instead of trying to explain something that we simply can't explain yet, we start just after the Big Bang. So within the first second after the Big Bang, we're going to get a drastic cooling of the universe. The temperature is going to cool to 10 to 27 degrees Celsius, which is still extremely hot, but not as hot as it was at the Big Bang. Once the temperature drops to 10 to the 27 degrees, matter can start to form. From matter, we can start getting electrons, protons, and neutrons. Now, when we go from 1 second to 3 minutes, we're going to get another drastic cooling. We're going to go from 10 to the 27 degrees Celsius to 10 to the 8 degrees Celsius. Then we're going to skip to 3 minutes to 300,000 years, a pretty big time frame. During this time, our temperature is going to cool even further. It's going to go from 10 to the 8 all the way down to 10,000 degrees Celsius. During this time, our subatomic particles, our protons, neutrons, and electrons, are able to form together to create atoms. Very simple light elements like deuterium, which is another form of hydrogen, lithium, and helium. From 300,000 years to 1 billion years, our temperature is going to cool even further. It's going to go from 10,000 degrees Celsius all the way down to minus 200 degrees Celsius. Now, again, with rapid cooling, we're able to do different things. Our hydrogen and helium atoms start to form giant clouds, which begin to have their own gravity, which attract more elements. These eventually will become our galaxies and stars. From 1 billion years to the present day, our temperature is going to cool a little bit further. So it's going to go from minus 200 degrees Celsius to minus 270 degrees Celsius. And at this point, our first heavy elements are going to be produced from our dying stars. So as our stars form, they're going to combine hydrogen to make helium. Eventually, those helium atoms are going to combine together to form larger elements. And then when our stars, our big stars, go supernova, they're going to spit out the other elements, the other heavier elements like lead, gold, stuff like that, eventually seeding the universe with all the elements that we currently have. Now, the universe is still expanding. We know this due to the phenomenon known as red and blue shift. When objects are moving away from it at a really fast rate, they appear red. And that's going to be shown in this diagram here on the right. So as our wavelengths get spread out, you can see the distance here is larger than the distance here. So with these larger wavelengths, we're going to get a shift towards red. And with very specific telescopes, we can pick up this red shift. When the objects are moving towards you, their wavelengths get contracted. That's these smaller wavelengths here. And therefore, they appear blue. Now, galaxies and stars move really, really fast. And as they're expanding away from a central point, they're going to be moving fast enough to create this red shift. Now, since we notice a lot of this red shift in the universe, we can see that things are moving away from each other, and we can use mathematical models to determine where these things are moving away from. And since they're moving away from a centralized point, it is theorized that everything must have been within that central point at t equals 0. It only makes sense that if we're going from here outwards, that at the beginning, we must have been at some kind of central point right in the middle. Now, again, we don't know what happened at t equals 0. At that point, our mathematics and our understanding breaks down. But what we do know is that the universe is indeed still expanding. Eventually, it will get larger and larger, and we don't know where it will end. Maybe eventually, once it reaches a certain distance away from that central point, maybe it'll contract again. Maybe that's what happened before. Maybe before our universe, there used to be a different universe that was way bigger because it had been expanding for billions and billions of years. And then eventually something caused it to contract again. After that contraction happened, we ended up in this central point. That central point became so dense that it couldn't do anything but expand again. So maybe the universe, as we know it, is simply a continual expansion and contraction over the course of everything. We simply don't know. But what we do know is that this concludes our lesson on galaxies, other objects, and the expansion of the universe.